Hi, and welcome to the Product Design Show. I'm Allison Topperwine.
And I'm Vince Penman. In this episode, we're going to take a look at some of the engineering and design that goes into the toys we all know and love. For most of us, our first exposure to design engineering comes when we are children in the form of toys. Whether it's a Slinky, Tickle Me Elmo, Lego, or Hot Wheels, we all had a favorite toy growing up. And well, you know, some of us never grow up. Fanboy exceptions aside, toys are meant for children. So in addition to the usual design challenges like minimizing production costs, toys have to meet particularly stringent safety standards. Toys have to be light enough to handle, but strong enough not to break when they get dropped. Toys for young children can't present a choking hazard. Companies are also paying more attention to the materials they use to ensure toys are not only safe and non-toxic for children, but for the environment as well. Sometimes toys are recalled after they've been released to the market because safety hazards are discovered. Earlier this year, a toy called O-Ball Links and Mini Rattles was recalled because the hard plastic C-links on both ends of the chain can break and create a choking hazard. A product called Snow Bikes was also recalled earlier this year because of the front ski could crack or break, causing the snow bike suddenly to stop, creating a serious fall hazard. And last year, sports company Bauer had to recall a series of children's hockey sticks because the product contained potentially hazardous lead paint. I say kids these days are soft. Back in my day, they made toys out of broken glass and steel. It's lucky that most of us all have our fingers and both our eyes.
In most countries, toys are extensively tested and have to meet a set of rigid guidelines before being certified as safe for sale. To test a toy, it's first subjected to a use and abuse test, where it's repeatedly pulled, tested, and dropped. Any small parts that come off are then subjected to small parts tests to see if they pose a choking hazard. Additional tests determine whether there are sharp edges and points that could injure a child. Paints used to color toys are also tested for heavy metals and toxic elements, including lead. We'd like to apologize to our more sensitive viewers for the toy testing images displayed. Let's observe a moment of silence to remember the toys that gave their lives so that our children could be safe. This is just unbearable.
Engineers and designers use sophisticated software tools like PTC's Creo parametric modeling solutions to design toys. This allows engineers and designers to virtually create the toys in 3D and render them in color so they can see how a toy will look before ever building a prototype. Engineers can virtually test toys by taking the software models previously developed and using a finite element modeling, or FEM software, to virtually test the toys and see how they'd hold up under stress.
Now you know what they say about all work and no play? The same software modeling programs engineers use to design heavy machinery and industrial equipment can also be used for less serious purposes. For example, if you get tired of digging through a big bucket of Lego blocks, you can make software models of those Lego blocks and use them to build virtual toys like cars, trucks, and helicopters. But don't get so caught up in that new hobby that you forget basic hygiene and social norms. Remember what happened when you started playing World of Warcraft?
Recognize this guy? Engineers at PTC made this model to spice up some of their product demos. If you'd like your own copy of PTC's Creo Elements Pro to play around with, just go to ptc.com/go/tryout to download a free for lifetime version from PTC. That's it for the Product Design Show this week. If you like the show, please give us a like on Facebook, subscribe on YouTube, or give us a rating on iTunes. Thanks for joining us. We'll see you next time.